One of the many ways we keep the quality of our code so high at MojoTech is by incorporating a code review into every pull request. To facilitate this, your branch history needs to be clear, concise, and made up of self-contained, non-breaking commits. This video assumes you know the basics of Git, such as add, commit, and branch, as well as more advanced commands like rebase. The goal of this video is to show you how to clean up a branch before submitting a pull request and how to incorporate the changes that result from the code reviews. The idea is that your final feature branch should be easy to read and review and simple to merge into the master branch. To do this, we'll be using Git rebase with the -i or interactive flag. As you work on your feature branch, and you are working on a feature branch, right? You should be making frequent commits. These are a good way to save blocks of work and be able to quickly see if something you just did is the source of a bug. However, a branch that looks like this is hard to review and makes any sort of bug searching later very difficult. In your branch's history, it sometimes makes sense to have a commit appear earlier than when it was originally created. In our contrived example, I've added a comment to the top of a file as my last commit, but in your branch this could be something like adding a library in somewhere along the way. It would make more sense if this commit were the first commit in our branch, so we're going to move it there. This is a very simple operation to do in an interactive rebase. If you're familiar with Git rebase, much of this will be familiar. First, we start off the interactive rebase by typing git rebase -i, and then the commit reference from which to begin the rebase. When working on a branch that was created off your local master branch, you can simply type master, and it will allow you to modify the entire commit history of your feature branch. This will put you into a text editor with the branch's commits and some text explaining your options. To move a commit, you simply move the line containing the commit's SHA and put it where we'd like it applied in the commit sequence. In our case, we're moving the commit beginning with 7b3d and the title, add comment to the top of the file, from the end of the commit history to the top. We're done with this part, so we save the file and quit, and Git performs our instructions. If we look back at GitX, we can see that the commit containing the comment is now the first commit in the feature branch. When committing frequently, you'll sometimes end up completing a piece of functionality across various commits or having a number of intermediary commits. You may also have commits that fix a previous commit or typo. You want your final branch to only have a single commit for each encapsulated code change. Fortunately for us, combining commits is just as easy. Looking back in our example, you'll see that our third commit says whoops and simply fixes the previous commit. This could have been added to the previous commit at the time with the commit command with the amend option, but we're past that now, so we're going to squash this commit with the second. Furthermore, our fourth commit is a whip commit or work in progress, and it's later finished in our fifth commit. To make this one logical commit, we'll squash the fourth and fifth together as well. Like before, the first thing to do is start an interactive rebase with git rebase, the -i flag, and our jumping off point. We'll find ourselves in our editor once again, but instead of moving commits around, we'll look at the commands Git offers us. Each command can be either specified by a single letter for a shortcut or the full command name before the commit's SHA. You'll notice that all commits have pick by default prepended to each line. This simply means to apply this commit in the order that it's in the file. To squash the third commit into the second, we'll leave the pick command on the second commit and we'll change the command on the third commit to squash it into the previous commit. Likewise, we'll pick the fourth commit and squash the fifth into it. With our changes made, we'll once again save the file and Git will do its thing. This time, however, it needs additional input from us. Git wants to know what it should do with the commit message of each commit when squashing them together. In this case, we have two messages, make a subclass and the whoops commit. By default, Git will use all commit messages, separating them by new lines. In our case, we don't want the second message, so we simply remove it. We save this file and quit our editor, and Git completes the squash. It then moves us to our second squash operation. In this case, we don't want the whip commit message, so we'll simply remove that. In addition, our now singular commit message is no longer completing the whip commit, but adding the final method all by itself. We have the option to actually change the commit message to whatever we want, so we'll just edit it in place here. Save it, and close the editor. And Git, not needing any more information from us, will complete the rebase. If we go back over to Git X, we can see that our rebase is complete, and we now have 3 small, concise, contained commits. Now our branch is ready for a pull request. Let's pretend that we've already submitted it for a pull request, and we've gotten back the following concerns: that the class, a subclass, is repeating so much of my class that it should simply inherit from it. Let's make these changes and use an interactive rebase to put them in the proper place. Now that we've made those changes, we can look at the difference between master and our feature branch. And we'll see that our branch is exactly where we want it to be. However, if we look at our commits, we'll see that we have this ugly commit at the end of our branch history that undoes and redoes some of the things that the previous commits did. Unless our code review revealed single commits doing too much or extraneous commits, we should have the same number of commits after the code review with the changes applied to the proper commits. We'll use one more interactive rebase to solve this. Once again, we'll start off with an interactive rebase, and this time we're going to take our commit that fixes up our previous commits and move it to where we want it, and then squash it into the commit that it's changing. We save the file. Git asks us for the commit message. We don't need the fixes from code review message simply because we're just simply adding it in. We save that, and now our rebase is complete. If we look at our commit history, we have the comment commit, the commit where we add the subclass, and the commit where we add one more method to that subclass. Our interactive rebase is complete, our code review is complete, and our changes have been merged back into our feature branch. We once again ping our teammates, telling them to review our feature branch, and should there be no more changes necessary, it's ready to be merged into master. Now, this was a contrived example and didn't have any conflicts. However, I hope that this video has taught you the necessary skills and familiarity with Git Rebase Interactive so that you can apply it to your own projects and use them to better your code quality by making clear, concise, contained commits and amending them with code review changes. Thanks for watching. If you have any questions, feel free to message us or leave a comment.